Okay, in the previous class we already discussed what happened inter-halogen compound. After the topic, the next topic is chemistry of chlorine. That means this is continued topic. So this chemistry of chlorine, so it was introduced by Singh. The scientist name is Singh. Then how to prepare this chlorine? This chlorine which can be prepared from a laboratory method. So these preparations are called isolation. These preparations are also called isolation. So how to prepare this chlorine? So in this chlorine which can be prepared from following methods, that is what happened. First, 4 moles of HCl. 4 moles of HCl that react to MnO2. That react to MnO2 to get, so MnCl2 plus Cl2 plus H2. That means chlorine which can be prepared from hydrochloric acid and MnO2. So after this next one, this chlorine which can be also prepared from, that is hydrochloric acid also. Second one, this 16 moles of hydrochloric acid that react to KMnO4. That react to KMnO4. Now here take 2 moles to get what happened here. K nothing but KCl, nothing but 2 moles of KCl plus Mn nothing but MnCl2. Mn nothing but MnCl2. So which is manganese 2 chlorine and plus H2. Here how many hydrogen is there? 16. That's right. 8H2. 8H2 plus Cl2 plus Cl2. Here 2 chlorine. Here 2 4. 4 plus 2 6. Now here take total 10. So here 10 plus total 6. 16 HCl. So this is chlorine prepared. The chlorine which can be prepared from hydrochloric acid and MnO2 and hydrochloric acid and KMnO4. At the same time, one of the most important chlorine prepared from, this is third one. These are called decon process. These are called decon process. How to prepare in the decon process of chlorine? In this chlorine, 4 moles of HCl. 4 moles of HCl that react to oxygen to get 2 Cl2 is formed. To get 2 Cl2 plus here 2 Cl2 nothing but 4 chlorine and then 2 H2O. This is methods of preparation of chlorine. This is methods of preparation of chlorine. This chlorine is also which can be prepared from Nelson cell process. What happened? Nelson cell process. So this Nelson cell process nothing but it is a diagram is there. What is the diagram? In this Nelson cell process, it is a rectangular iron tank. Now it is U-shaped tube. Now this tube which can act as cathode. So this is asbestos lining. This is asbestos lining. Now in this tube, graphite is kept in this tube. Graphite is kept in that. Here, this is heating coil. Now asbestos lining in the side of the tube. This is asbestos lining. So this is receiver. This is receiver. Now there are following open system. This is one inlet, and this is also inlet. This is what happened for outlet. This also outlet. So what are the outlet? This is in. This is in. When steam sent to in. When steam sent to in. That steam sent to in here brine. That means NaCl. Now this is U2. This which can act as cathode. This U-shaped tube which can act as cathode. This graphite rod. Graphite rod which can act as anode. And this is chlorine outlet and here hydrogen is outlet. Now in this one what happened? When steam sent to in. When steam sent to in, that steam, that NaCl that reacted to steam to get what happened? NaCl. Yes, NaOH and HCl. These chlorine gas is liberated at anode side and hydrogen gas is liberated at cathode side. So this is what happened Nelson cell process. for the preparation of chlorine. So in this Nelson cell process, here it is a U-shaped tube which can act as cathode, graphite rod which can act as anode. In this tube, this is inlet, outlet. When steam sent to in, that means steam is going water vapor like that. Steam sent to in, then HCl is both steam and HCl. These two are react to each other to get NaOH. That NaOH are collected at the bottom of the tank. NaOH are collected at the bottom of the tank, that is reservoir. Other gas are outlet for the gases. That is hydrogen gas is liberated at cathode side and chlorine gas is liberated at anode side. So this is chlorine prepared. Then chlorine which can be prepared from, these are the preparations. And chlorine is also prepared from Caster Kennel cell process also. So this is methods of preparation of chlorine. The next one, chemical properties of chlorine. Chemical properties. After this one, chemical properties of chlorine. Chemical properties of chlorine. So these chemical properties of chlorine are basically following types. What are the chemical properties? Now in this one, first, these chlorine react to first react to hydrogen. React to hydrogen. That means H2 plus Cl2 to get 2 HCl. At the same time, this chlorine is also prepared from decline, that is C10H16 plus 8Cl2 to get what happened 10 moles of carbon and what happened plus 10 moles of carbon, then 8Cl2, that means 16 HCl. So which means what happened 16 moles of HCl is formed. So this is react to hydrogen. The next one, react to water. React to water. That react to water means here chlorine react to water. React to water to get what happened HCl plus HOCl. HCl plus HOCl. This HOCl nothing but hypochlorous acid. In the name is hypochlorous. Hypochlorous acid. This hypochlorous acid, HOCl, hypochlorous acid is dissociated or decomposed to get what happened HCl plus a nascent oxygen is formed. A nascent oxygen. That's why this hypochlorous acid is a good bleaching agent. This hypochlorous acid is a good bleaching agent. Next, after this hypochlorous acid, the next one, react to base. That means alkalis. So that react to alkalis. The react to alkalis. The best example of alkalis is NaOH. That means react to NaOH. What is the react to NaOH? Nothing but first chlorine react to 2 moles of NaOH. React to 2 moles of NaOH to get NaCl and NaOCl. To get NaCl plus NaClO3 plus, so NaCl plus NaOCl. NaCl and NaOCl. So what is the meaning of this means? So here NaOCl plus H2 plus H2. This is in the dilute condition. What about in the concentrated condition? Now again 3 moles of chlorine which react to 6 moles of NaOH. Which react to 6 moles of NaOH to get 5 moles of NaCl. 5 moles of NaCl plus NaClO3. NaClO3 plus 3H2O. NaClO3 plus 3H2O. So this is chlorine react to dilute condition and concentrated condition to get what happened NaCl common thing, NaOCl and NaClO3. So this is chlorine. The next, after react to base. After that, react to what happened? React to metals. React to metal. Now here metal, the best example is when fluorine react to chlorine. 2 moles of fluorine that react to 3 moles of chlorine to get 2 moles of FeCl3 is formed. FeCl3. At the same time, after that metal, copper also another second example is this one. So copper Cu react to Cl2 to get CuCl2 to get CuCl2. Now after metal, the next one non-metal. Non-metal, the best example is following example, when sulfur react to chlorine to get S2Cl2, that means sulfur monochloride. After this one, when phosphorus react to acid, so this is this one. So at the same time, this is non-metal. Next one, hydrocarbon. Sixth one is hydrocarbon. These hydrocarbons are These hydrocarbons are basically following types. What is that? The hydrocarbon means these are two types, saturated and unsaturated. These are two types. That is one saturated, one is saturated, and second one is unsaturated. So what is saturated? Now when saturated means carbon-carbon single bonds. When carbon-carbon single bond, that are called saturated. When carbon-carbon double bond or triple bond, that are called unsaturated. Simply this one. Saturated, the best example is methane. Methane reacts to chlorine in the presence of sunlight to get monochloromethane. CH3Cl plus HCl. CH3Cl plus HCl. Now this CH3Cl, CH3Cl, that reacts to chlorine in the presence of sunlight to get dichloromethane. That nothing but CH2Cl2 plus HCl. That dichloromethane, that formula is CH2Cl2, then again react to chlorine in the presence of sunlight to get CH2Cl3 and HCl. This CH2Cl3 is nothing but what happened? Chloroform. This is nothing but chloroform. And then again that chloroform CH2Cl3 that react to Cl2 in the presence of sunlight to get carbon tetrachloride, then HCl. This is what happened? Hydrocarbon saturated. That means what happened? When methane react chlorine to get monochloromethane, react chlorine in the presence of sunlight to get dichloromethane, react chlorine in the presence of sunlight to get trichloromethane, is nothing but chloroform. Then chloroform react chlorine in the presence of sunlight to get carbon tetrachloride. So this is what happened. So first, what is chemistry of chlorine? Chlorine, it was introduced by the scientist name is Singh. So that first one is methods of preparation of chlorine that are called isolation. So 4 moles of HCl, hydrochloric acid, that react to manganese dioxide to get chlorine is formed, to get chlorine. Now after again, now hydrochloric acid that react to KMnO4 to get chlorine is formed. Now these are called decon method. Hydrochloric acid react to oxygen in the presence of CuCl2 to get chlorine is formed. So this chlorine which can be prepared from Nelson cell process also. Now this is the Nelson cell process diagram. So this is a U-shaped tube which can act as cathode. This graphite rod which can act as anode. Now this is in the bottom of the tank, steam, in the top of the tank, brine solution sent to in. That means this is brine solutions. Now its formula is NaCl. Now this chlorine and hydrogens are outlet. In the bottom of the tank, one residual is there, that is collected of NaOH. So what happened? Now when steam sent to in, steam means water vapor. Steam sent to in, that steam react to NaCl. That NaCl is comes down. These two react to each other to get NaOH. This NaOH as a byproduct. And the hydrogen chloride, the hydrogen gas is liberated at cathode side and chlorine gas is liberated at anode side. This is methods of preparation of chlorine. After this, now this is what happened, chemical properties of chlorine: react to hydrogen, react to water, react to alkalis, react to metal react to chlorine to get metal chloride, non-metal, sulfur react to chlorine to get sulfuryl chloride, that means sulfur monochloride, hydrocarbon, these are two types, saturated and unsaturated. Saturated means carbon-carbon single bond. Now after that, after this isolation, next goes to unsaturated hydrocarbon. What is the unsaturated hydrocarbon? Unsaturated hydrocarbon nothing but carbon-carbon double bond or carbon-carbon triple bond. Simply here CH2 double bond CH2 that react to chlorine. To get what happened, this double bond is converted to single bond. After converting single bond, these two chlorine migrate both the carbon side. Simply this one. Here what happened? Chlorine. This side also chlorine. Each carbon equal to how many valency? 4. That's why this is CH2. This is what happened? CH2. Its name is 1,2 dichloro. 1,2 dichloroethane. 1,2 dichloroethane. So now after this unsaturated hydrocarbon, the next one, seventh one is react to carbon monoxide. React to carbon monoxide. So here carbon monoxide react with chlorine to get COCl2, carbonyl chloride. This carbonyl chloride nothing but pozine. This carbonyl chloride nothing but what happened? Pozine. After this carbonyl chloride, now eighth one is NO. So that means 2 moles of nitrogen monoxide react to chlorine to get nitrosyl chloride. To get what happened? Nitrosyl chloride. That formula is NOCl. Ninth one is SOCl, SO2. SO2 nothing but sulfur dioxide. So what happened here? Sulfur dioxide react to chlorine to get sulfuryl chloride. To get what happened? Sulfuryl chloride. The next after this one, so these are react to water, react to H2, react to water, react to alkalis, metal, non-metal, hydrocarbon. After that hydrocarbon, these are two types, one saturated and second one is what happened? Unsaturated. After that unsaturated, react to carbon monoxide. When carbon monoxide react to chlorine to get carbonyl chloride is nothing but pozine. Nitrogen monoxide, NO react to chlorine to get nitrosyl chloride. Sulfur dioxide react to chlorine to get sulfuryl chloride. The next one, last one, react to halides. Last one, react to halides. What is the react to halides? That means 2 moles of Ki. 2 moles of Ki that react to Cl2 to get 2 moles of Ki react to Cl2, 2 KCl plus I2. 2 KCl plus I2. This is next one more very important equation, that is ammonia. One more very important equation, that is ammonia. So ammonia, this one, when ammonia, 8 moles of ammonia that react to 3 moles of chlorine. 8 moles of ammonia which react to 3 moles of chlorine to get what happened? 6 moles of NH4Cl. 6 moles of NH4Cl plus N2. The same time 4 moles of NH3. 4 moles of NH3 which react to 3 moles of chlorine to get NH4Cl, same thing, NH4Cl plus NCl3. NH4Cl plus NCl3. That means in this equation, what is that equation? When 4 moles of NH which contain here 3 nothing but here take 3 moles. So this is what happened, react to chemical properties of this chlorine. After this one, then uses is there. Uses. So what is the chlorine uses? It is used in sterilization of water. It is used in sterilization of water. Sterilization. It is used in sterilization. Sterilization of water. Sterilization of water because it kills bacteria. Because it kills. Because it kills bacteria. It kills bacteria. Because it kills bacteria. So that means it kills bacteria. Next one, it is used for the preparation of pozine. It is used for the preparation of pozine, and it is also also used in the preparation of pozine, and it is used for the preparation of chloroform, dichloromethane, monochloromethane, and it is used for the preparation of chloroform. It is used for the preparation of chloroform, and it is used in the preparation of mustard gas. Mustard gas formula is Cl so it is also prepared of mustard gas. Mustard gas. Okay, this is what happened, completely chemistry of chlorine. So this chemistry of chlorine, now we can touch just boundaries. So what is the chemistry of chlorine? This chemistry of chlorine which can be prepared from what is the preparations? Following preparation is there that are called isolations. So HCl react to MnO2 to get the MnCl to Cl2 plus H2O. At the same time, decon process also equation is there. 4 moles of HCl that react to O2 to get Cl2 plus water. The next one, after that, this chlorine it was introduced by serious scientist. The next, this chlorine is a greenish yellow in color, and it is a pungent ordered gas. It is a pungent ordered gas. And chemical properties of chlorine. These chemical properties of chlorine is H2 react to chlorine to get hydrochloric acid. These equations slow in dark, fast in sunlight. Slow in dark, fast in sunlight. The next one, Decli react to chlorine to get hydrochloric acid. Then water, chlorine react to water to get hydrochloric acid and hypochlorous acid. This hypochlorous acid is thermally dissociated to get HCl and oxygen. These oxygen are called necessary oxygen. That's why this equation is a good bleaching agent. It is a good bleaching agent. It is a good bleaching. It is a good bleaching agent. That's why it is a good bleaching agent. The next one, alkalis. When chlorine, one dilute condition and one is concentrated condition. When chlorine react to alkalis to get NaCl and NaOCl. The same time, here replace of NaClO3, metal react to chlorine to get metal chloride, non-metal, hydrocarbon, saturated and unsaturated. And one more equation is also, then what happened? The carbon monoxide react to chlorine to get carbonyl chloride, nitrogen monoxide react to chlorine to get nitrosyl chloride, sulfur dioxide react to chlorine to get sulfuryl chloride, halides, potassium iodide react to chlorine to get iodine is formed, ammonia, one excess of ammonia, another one is excess of chlorine. Now one more equation is also there in this one. What is that? When Slackert-Line react to chlorine. So one more equation is there, that is when Slackert-Line. So I think that is 12th one. CaOH taken twice. CaOH taken twice react to chlorine to get bleaching product is formed. That is CaOCl2 plus H2O. CaOCl2 plus H2O. After that, uses. It is used in sterilization of water because it kills bacteria, and it is also for the preparation of poison, and it is also used as solvent like chloroform and dichloromethane, and it is used for the preparation. It is also used in mustard gas, and so this is, and it is also used in Levisite. So what is the formula of Levisite? That Levisite means, for example, here Levisite, CH triple bond CH, CH triple bond CH, that reacted to AsCl3. So how to form this one? This AsCl3, AsCl2 plus and Cl minus. That's why Cl minus migrate from one side, other are migrate from another side. That's what happened. This is migrate to AsCl2 and Cl minus. So that's why what happened? H2 AsCl2 HC double bond CHCl. These are called Levisite. So this is completely chemistry of chlorine. After this chemistry of chlorine, next topic is goes to Oxy Acids of Chlorine. Oxy Acids of Chlorine. Now, these Oxy Acids of Chlorine are basically following types. So that is hypochlorous, chlorous, chloric and perchloric. Next topic is goes to Oxy Acids of Chlorine. So what is the Oxy Acids of Chlorine? Now these Oxy Acids of Chlorine are basically 4 types. That is 1 hypochlorous, chlorous, chloric, then perchloric. Simply next topic is goes to Oxy Acids of Chlorine. oxy acids of chlorine. So these oxy acids of chlorine, today we discuss just what is the structure of this oxy acids of chlorine. We discuss just what is oxy acids of chlorine. Basically these oxy acids of chlorine are 4 types. That is one HClO, second one HClO2, third one HClO3, fourth one HClO4. This HClO nothing but hypochlorous. Its name is hypochlorous. And the second one is only chlorous. Third one is chloric. And fourth one is perchloric. Now let us we discuss one by one. Now first what happened? HClO. This is first we find oxidation state. What is the oxidation state of this one? 1 plus x plus minus 2 equal to 0. 1 plus x minus 2 equal to 0. X equal to what? 1. That's why one unpaired electron degree takes place. So what is the electronic configuration? This electronic configuration is NH2NP5. So what happened in this one? Yes, it contains 1, 2 and P contain 3 orbitals and 5 electrons. 1, 2, 3, 4, 5. So what happened? This structure is linear. That means chlorine is the central. It contains how many? 1 OH. It contains 1, 2, 3. 1, 2, 3. So its shape of the molecule is linear. Its shape of the molecule means it is linear. All these oxy acids of chlorine undergoes sp3 hybridization only. All these undergoes sp3 hybridization. It undergoes sp3 hybridization. Here 1 OH means it is 1 basicity. It undergoes sp3 hybridization. Its oxidation state is +1. Now it is the shape of the molecule of linear. Now after this hypochlorous, the next one is hypochlorous perchloric acid. So what is the meaning of this perchloric acid? Right, I am using for this side. Second one is perchloric acid. So that formula is this one, HClO2. Now first we find the oxidation state. What is the oxidation state here? Oxidation state 1 plus x minus 4 equal to 0. Simply x equal to what happened? 3. The 3 means 3 unpaired electron will be takes place. The 3 unpaired electrons are where? In the first excitation state. That's why what happened in first excitation state? It contains 1, 2. And P contain what happened? 3 orbitals. 1, 2, 3, 4. And D contain 5 orbitals. How many unpaired electrons? 1 unpaired electrons. Okay. So, but it is not sp3d hybridations. So that means here chlorine is the center. So it contains how many OH? 1. This is 1 OH. Okay. The remaining 1 O is there. That is double bond O. This is double bond O. Now it contains how many load pair? 2. This is 1. This is 2. Its shape is V shape or bent. V shape or bent shape or angular. V shape or bent shape or angular. This is what happened. That means what is the hybridization? It undergoes sp3 hybridization only. sp3 hybridization. Its shape of the molecule is V shape or bent shape or angular. Okay. Its bond angle is 111 degrees. And its contain, this is sigma pi. So this is also sigma. How many sigma? 1, 2. 2 sigma. This is sigma. This is pi. This is only sigma. That's how many sigma? 2 sigma 1 pi. It contains 2 sigma 1 pi. So after this, next topic is goes to next one. What happened? HClO3. Third one is HClO3. What is this meaning of this HClO3? Next HClO3. First we find oxidation state. This one, chloric acid. So this is chloric acid. First we find oxidation state. What is the oxidation state of this one? In oxidation state is 5. 1 plus x minus 6 equal to 0. X equal to what happen? 5. Now 5 means 5 unpaired electron will be takes place. 5 unpaired electron where? In the second excitation state. Now that is in the second. S it contain only 1, 2 and P contain 3 orbitals, 3 electrons and D contain 5 orbitals, what happened? 2 electrons. Its structure is like this. Chlorine is central metal. It contains 1 OH. Okay. Here how many chlorine is there remaining? 1 OH. 1 OH remaining 2 oxygen is there. That's why this is double bond. It will be also double bond. The remaining only paired electrons. This is this one. Its structure is pyramidal. It is pyramidal in structure. It is pyramidal. So how many sigma? This is sigma. This is pi. This is also sigma. This is pi. It is sigma. That's why 3 sigma 2 pi. 3 sigma 2 pi. This is hypochlorous, chlorous, hypochlorous, chlorous, chloric. The next one, last one is perchloric acid. Last one is perchloric. I am writing for this side. What is the perchloric acid? This perchloric acid nothing but that formula is HClO4. Now last one is perchloric acid. That perchloric acid ka formula is HClO4. So what is the meaning of this HClO4? This HClO4 is the stable compound. That HClO4 is the stable form of other three. So that is simply, so this is fourth one is perchloric acid. Perchloric. That formula is HClO4. Formula is HClO4. Now first we find oxidation state. 1 plus x minus 8 equal to 0. X equal to what happened? 7. So this is second excitation state. Of course here what happened? Third excitation state. What is third means? S it contain only 1. P contain 3 orbitals, 3 electrons. And D contain 5 orbitals. How many electrons? Only 3 electrons. But it is not sp3d hybridization. It is not sp3d3 hybridization. It is also sp3 hybridization. Simply what happens? Its structure is like this. Chlorine is central. It contains 1 OH. It contains 1 double bond, second double bond, third double bond. So its shape of the molecule is tetrahedral. Its shape of the molecule is tetrahedral. So then already discussed. If tetrahedral is there, that bond angle is 109 degree 28 minutes. That bond angle is 109 degree 28 minutes. Its bond angle is 107 degree. Its bond angle is 111 degrees. Right now, so this is what I mean. Now what is the hybridization? It also is sp3 hybridization. It also shape of the molecule is tetrahedral. It contains how much? 1, 2, 3, 4. 4 sigma and 1 pi. It contains one basicity. One basicity means one basicity are depend upon OH groups. Basicity are depend upon OH group. This is oxy acids of chlorine. What is the oxy acids of chlorine? This oxy acids of chlorine. But the oxy acids of chlorine is formed. But the oxy acids of chlorine is not there. Oxy acids of chlorine is cannot form. Only oxy acids of chlorine is formed 4 types. That is hypochlorous, chlorous, chloric, perchloric. So hypochlorous means, for example, so here is the graph. So what is the graph? Nothing but, now here for example, this is fluorine, chlorine, bromine, iodine. It is formed only, this is hypochlorous, chlorous, chloric, perchloric. It is only one form. It is hypochlorous, chlorous, chloric, perchloric. It is hypobromous, bromous, bromic, perchromic. Hypoiodous cannot be formed. This one, this one. So this is what happened completely. This oxy acids of chlorine. So what is the oxy acids of chlorine? These are 4 types: hypochlorous, chlorous, chloric, perchloric. Hypochlorous. First we find oxidation state. What is the oxidation states of here? Oxygen oxidation state is -2. Hydrogen oxidation state is 1. That's right. Its oxidation state is 1. So it one unpaired electron which excitation states directly in the first excitation state. That's right. In the first excitation state. Now it is not now all these oxy acids of chlorine undergoes sp3 hybridations only. Now it's a the chlorine is central atom. It contains only one OH. Remaining 1, 2, 3. 3 are lone pair. It's a of the molecule linear. It is sp3, 1 OH. Second one where this side. That is what happened HClO2. Hypochlorous. This is chlorus. Its name is chlorus. Its name is chlorus. Its name is chlorus. Its name is chloric. Its name is chloric. Now where this name is perchloric. Its name is perchloric. Its name is perchloric. Now what happened that hypochlorous acid is it is V-shaped or bent shape or angular. It is pyramidal in shape. It is tetrahedral in shape. So then oxides of chlorine methods of preparation of oxides of chlorine is there, and chemical properties of oxides of chlorine is there. So the topic we discuss on next class. So this is what happened today topic. Okay. So to be continued on next class. Okay. Thank you.